Hi, this is a demonstration of the process of calculating DFT of PPG plus powerline array. This is the original data containing 5 samples. This is stored in an array named X. And then we will store the real part and imaginary parts of the DFT output in these arrays Y and Z respectively. And then we will store the magnitude of the DFT output in the array F. And these two arrays are calculating the inverse DFT. Firstly, we begin the serial communication at a baud rate of 9600. Then we initialize all the sum values as 0, and then we initialize these two arrays with 0 values. Now we iterate through the array, and then we calculate the sum, and we calculate the DFT using the formula x of k equal to x of n into e power minus j omega n and summation. And then that e power j omega n can be expressed as sum of cosine and sine terms. And then we'll calculate the magnitude with the help of this formula, square root of real part square plus imaginary part whole square. And then we'll plot the output of the DFT. And now we can see the output in this is the output. We can say that the output of DFT is higher at both the ends, at the initial values of the samples and the final value of the samples. The middle values, for the middle values, the output is very negligible. Here the output increases again. So now we can uncomment this line. And now for calculating the inverse DFT, uh, we pass the DFT through a bandpass filter with a lower cutoff frequency of 0.5 Hz and upper cutoff frequency of 30 Hz. Uh, by using the formula f equal to kfs by n, we calculate the sample numbers, and we take only those samples and keep all other samples as 0. Uh, by using the formula, we will get the samples as 2 and 77. We will take the samples between these for passing the output through the bandpass filter. Now, this array consists of the output of the bandpass filter, and then we'll calculate the inverse DFT with this formula. We will initialize the sum of real and complex imaginary parts every time 0, and then we will calculate the inverse DFT by calculating the summation and then dividing it by the number of samples. For inverse DFT, we consider only the real part of the samples. So we can upload this code, and then uh, we will only consider the real part of the output, and then we'll plot the output. Mhm. So this is the output of the inverse DFT. So as you can see, this is all almost similar to the output of the original data. We can also see both the plots at the same time. Okay, so um, these are the plots of the input and the um, input calculated using inverse DFT. As you can see, the shape is almost similar, but the magnitude is a little different because of the scaling factors. We can adjust that, and then we can get the desired output much more accurately. So thank you.